Today's lesson is on slope, and it's found in 4.6 in your books if you'd like to follow along. Before we get into our objectives today, let me just say that if you like more of the numbers part, the algebra, the adding, subtracting, dividing, multiplying, whatever, this is your lesson. This is the one that you're going to really latch on to and hopefully understand. So if you like the midpoint stuff, you'll like this too. There is some geometry involved as far as what you'll need to know, depending on what they're asking, but we'll get into that. So first objective is to understand the concept of slope. The next one, you need to be able to relate the slope of a line to its orientation on the coordinate plane. And finally, recognize the relationship between the slopes of parallel and perpendicular lines. So let's start at the beginning with the definition of slope. The slope M of a non-vertical line segment array containing x sub 1, y sub 1, and x sub 2, y sub 2 is defined by the formula M, or slope, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or you could also do y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Entirely up to you. The order doesn't matter. What it's basically saying, don't get hung up on the sub 1, sub 2. All it means is that we need to differentiate between this y and this y. So as far as the formula goes. So if I'm going to take this y and subtract this y from it, I need to start with this x and subtract that x from it. Okay, that would be this one. You can start with this y and subtract that one from it, but then you must start with the same x and subtract the other x from it. So see how they match up vertically? You've got your y sub 1 and your x sub 1 matches right there. Or here you have your y sub 2 and your x sub 2. That's this coordinate pair. So you have to start with whatever it is, your x or your y, from the same coordinate pair in the numerator and denominator spot. All right, so let's actually see it in use. Okay, we need to find the slope of a segment joining negative 2, 3, and 6, 5. And I'm going to show you both ways just to show you that it does work regardless of what order you do it in. So we start off with our slope formula. Okay, so here I did this y and this y. I started with the y sub 2 and subtracted 3 from it. Okay, and then since I started with the 5, I had to start with 6 and subtract negative 2. And I did the opposite down here. I did 3 minus 5 over negative 2 minus 6. Now this is what you want to be careful of. Okay, because when you subtract a negative, you actually have a positive. You're adding a positive. So you would end up with 2 over 8. Over here, you would end up with negative 2 over negative 8. But they both come out to be 1 over 4 because these two negatives cancel out. So either way you do it, you're going to get the same answer. Okay, now undefined slopes are if the slope formula is applied to a vertical line, meaning it goes up and down, the denominator will be 0. Division by 0 always results in the answer being undefined, so a vertical line has no slope. So take this example. Here we've got our point A and point B. And notice that their x's are the same. Oop, let me go back to that. Okay, their x's are the same. Stop. Okay, so we start off with our y's, 12 minus 2, which is 10. But then because the x's are equal, 6 minus 6, that equals 0. You can't divide by 0. So your slope is undefined. Okay, now zero slopes. Okay, you don't confuse an undefined slope with a slope of 0. If you have a horizontal line, meaning it runs left to right straight across, you're going to end up with a numerator of 0, not a denominator. And anytime 0 is divided by a number, you do get an answer. The answer is 0. So we say a horizontal line has a 0 slope. Now, if you want to look in your books for what the different slope, what a negative slope, what a positive slope, what an undefined slope, and what a 0 slope looks like, go to page 199 in your books. They've got some good diagrams in there. Okay, now we get into more of how you're going to use this in geometry, the slopes of parallel and perpendicular lines. There are 4 theorems associated with this. Okay, if two non-vertical, you're going to see that a lot, non-vertical. Make sure you know that. It's got to be non-vertical. Lines are parallel, then their slopes are equal. Which makes sense because they're never going to cross. So if the two lines have the same slope, they're never going to cross. They're parallel. And you can use the opposite of that because this definition this theorem, actually we split it into two, but it works both ways. So if the slopes of two non-vertical lines are equal, then they are parallel. Remember, theorems are not always, you can't always reverse them, but sometimes you can. So we write it as two separate theorems. Okay, so that's parallel lines. Now perpendicular lines are a bit different. If two lines are perpendicular and neither is vertical, each line's slope is the opposite reciprocal of the others. Okay, and then we have theorem 29, which basically says the same thing but flipped. If a line's slope is the opposite reciprocal of another line's slope, the two lines are perpendicular. So I'll show you an example coming up here what that means for you, because that might not make sense right off the bat just reading it. All right, so let's say that we've got triangle ABE, and we need to find the slope of altitude AC and the slope of median AD. Okay, so I already drew in AC and AD for you there, so don't worry about that. I have no idea what happened here. I decided to convert some of my letters to shapes, so just bear with me. So we can find this. First thing we need to do is find the slope of BE, which I chose to do 5 minus 3 over 6 minus negative 4, which is the same as 2 over 10, which means that the slope of BE is 1/5. Now, an altitude forms a perpendicular line, don't forget. So that's where this comes into play. Now, the opposite reciprocal of 1/5, okay, the opposite of 1/5 would be negative 1/5. The reciprocal is where you take the fraction and you flip it. So it would be negative 5. If we're going with the opposite first and then the reciprocal, it would be negative 5 over 1, or just negative 5. Okay, next we need to find the slope of the median. Well, to do that, first we need to figure out where this AD is, because we need to find that. Remember, the median goes to the midpoint. So the midpoint of segment BE, we use our midpoint formula. So we take negative 4 plus 6 and divide it by 2, which gives you 1, so that's right at 1. And then y, we do 5 plus 3 and divide it by 2, which is 4. So this point right here would be at 1, 4. And then we find the slope of AD, because now we've got our 2 points. So I take my y's. I started with this one. I did 10 minus 4, and then I would do negative 2 minus 1, which gives me 6 over negative 3, which gives me a slope of negative 2. Or you could say negative 2 over 1. It's entirely up to you. So again, the main thing I want you to focus on here is that we've got 1/5, and the opposite reciprocal is negative 5 over 1. So example, I'm going to try and write this with the mouse, so bear with me. So if, let's say I had a slope of something that was 2 over 3. The opposite reciprocal would be negative 3 over 2. Okay, if I had a slope of negative 4/5, say, the opposite reciprocal would be positive 5 over 4. All right, so you get the idea. We'll be working with this a little bit in class, but once it clicks, you're good. You're golden. You'll have no problems. So anyway, this will be due for Wednesday, so you have plenty of time to watch it and take notes. And if you have any questions, as always, ask me in class. Thank you much. And so there you go. Your answer for B was